In this presentation, I'm going to give you an overview for what we're going to be covering during week 3. And essentially what I'll be doing is introducing the fundamental concepts associated with hypothesis testing and how to implement a particular hypothesis test. So remember or recall that statistics enables us to make inferences using our data. And primarily, this is sort of the application that we see of statistics in engineering and science. In this concept map, you can see how concepts are related to statistical inference. In our case, basically how a hypothesis test is some form of a statistical inference. So let's go through this concept map a little bit deeper. Basically, a statistical inference is the process of drawing conclusions about a certain population. And based on data from some members of the population, which we would call our sample. So essentially, we infer something about our population using a sample. So for example, let's say our population could be a batch of photovoltaic cells or solar cells as they're called, and let's say we need to select a sample, say 5 randomly selected solar cells, and we want to test to see whether or not what their maximum power output is. And essentially what we can do is, using that sample, we can use statistical inference to determine the average power output for that batch. And so using the sample, we can essentially infer about the population. And in our case, we're inferring the average power output of a solar cell. And this is essentially an example of a parameter estimate. So our power output, so that maximum power output from a cell, becomes our parameter estimate. Or we may want to know, for example, or may want to be able to make decisions about, let's say, that average power output in order to determine if that power output is large enough so that we can use it in the marketplace. And we would do that, make that decision using hypothesis testing. So in this class, we are going to actually spend a lot, or the bulk of our class, doing hypothesis testing or some form of tests of the hypothesis. So let's look at a concept map for the hypothesis test. And essentially a hypothesis test allows us to make a decision or decide about certain hypotheses that we have. So in our case, it allows us to decide to accept or reject the hypothesis based off of the parameters for our population. So in our solar cell example, the hypothesis could have been the average output of a solar cell is 0.5 watts, and using that data, we accept or reject the hypothesis. So let's say the average ended up being less than 0.5 watts, then we would actually reject the hypothesis, and maybe we would, as engineers, have to go back and do some quality issues to see what is actually going on with our production process such that our solar cells are so low. Because the data we use has variability, our decision to reject or accept that hypothesis could essentially, or in certain cases, be incorrect, and we would call that error. So in hypothesis testing, we decide to reject or accept the hypothesis by assuming a certain level of risk for making error. So and what we essentially do is, and one of the things we'll talk about later on, is we have a certain level of confidence associated with these hypotheses, these decisions that we're making, and but even in those confidence, even with that confidence, we still are assuming a certain amount of error. In this course, hypothesis tests are conducted by computing a test statistic, which is essentially a function of our data, and typically we use the average or sample mean. And based off of this test statistic, we can essentially run, in our case, we will cover 4 different tests. So our first one is a test of the mean, where we know the variance, so the variance of the population. The test of the mean, where we don't know the variance of the population. A paired t-test, which essentially allows us to compare 2 different populations. And an ANOVA, which is a comparison test that allows us to compare typically 3 or more populations. And so this week, what we're going to essentially do from start to finish is we're going to first introduce the concepts of hypothesis testing, since this is sort of the bulk of our ability to infer from data in engineering and statistics. Then we're going to describe errors and how they can result, and our assumptions of errors and how that affects our choice of a specific threshold. Then we're going to show how to compute sample statistics using a particular type of particular type of test statistic. And typically in our case we use a sample mean. And then lastly, we're going to show how to use those values determined in our test statistic to compute various confidence intervals. So that's associated with our error and our ability to say, yes, we're confident about some of these tests that we're running. And again, these are typically based off of an estimate of the mean, which is just essentially a parameter estimate or a parameter estimation. So I hope you understand everything that we're going to be covering in week 3. Thanks.